Welcome back to 11.1. This is part 2. Just a reminder that chi-square tests are for categorical data only. Okay, so that means that we somehow need to be able to turn our data into counts of people, even if our data is somehow numerical by nature. Okay, now what are the conditions for conducting a chi-square goodness of fit test? Because as we saw on the previous page, we just kind of marched through and found some chi-square value and talked about the p-value and figured out if it failed to reject or rejected our HO. Okay, and then here's more about the rest of the four-step process that we're missing. We still have to check the conditions of random, independent, and large counts. The random sample or random assignment in the randomized experiment is required. Independence, we need to check for a finite population without replacement that our sample size is less than 10% of the population size. And all large counts, all of our expected counts must be greater than or equal to 5. That means our expected counts, not our observed counts, okay? And they have to be counts, not percents. Okay. So landline surveys, and I wrote a note to myself that this really needs to be updated. Why do we have a story about landlines? Okay, anyway, so just go with it. According to a year 2000 census, before you were born, of all U.S. residents aged 20 and older, 19.1% are in their 20s, 21.5% are in their 30s, 21.1% are in their 40s, 15.5% are in their 50s, and 22.8% are 60 and older. The table below shows the age distribution for a sample of U.S. residents aged 20 and older. Members of the sample were chosen by randomly dialing landline telephone numbers. Do these data provide convincing evidence that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents? So we have the proportions of people based on just the U.S. Census that are in each age category, and then the actual counts of people that have a landline cell phone from a random sample. And then, okay, ready? Here we begin. State, we wish to test HO, the age distribution of people who answer landline phone surveys is the same as the age distribution of all U.S. residents. Okay, remember that this is always our no change or they're equal or something like this. Okay, so the age distribution from people in the U.S. Census equals the distribution of people with landline phones. Okay, equals. HA is that somewhere we have values that are not equal. So HA ... is not the same, okay? So the age distribution of people who answer landline phones is not the same as the age distribution of all U.S. residents. Tested alpha equals 0.5. Plan, perform a chi-square goodness of fit test. Random sample of landline users. Good. Independent, 1048 is less than 10% of all U.S. residents age 20 plus. Good. Large counts. 1040 times the first one, 0.191, equals 200.17. And see the table. Here's all my expected counts calculated. Okay. All expected counts are greater than or equal to 5. What's the meaning of this then? I should show a little bit of work to show how I'm finding these expected counts instead of just looking like maybe I'm copying from a friend or I'm just making these up. Okay, or I'm just finding them on the calculator. Okay, all conditions are met. Chi-square is observed minus expected squared over expected. Okay, then we do the next component. Observed minus expected squared over expected, plus, and then ... Now, there are only 1, 2, 3, 4, 5 of these, so I could show them all by hand, but I just showed a ... because it's a time saver. Chi-square equals 48.2. Wow, that should stand out to us as quite large. Degree of freedom is 4 because it's my number of categories, 20s, 30s, 40s, 50s, and 60s. That is 5 categories, minus 1 is 4. P-value, very close to 0. I can find that in chi-square CDF, lower, upper degrees of freedom. Okay, because our p-value of approximately 0 is less than alpha equals 0.05, we reject HO. There is convincing evidence that the age distribution of all U.S. residents is different or not the same as the age distribution of landline survey takers. Can you do chi-square on your calculator to conduct a GOF test. The TI-83s cannot. So people with the old black calculators cannot do this, but you can do it if you have the newer versions. It's stat tests option D, chi-square goodness of fit test. All your observed counts need to go into your L1. All your expected counts need to go into your L2. So you still have to find those expected counts yourselves. Now, you could always just make a little program in your L's though, and you could put the probabilities in your L2, and then in your L3 write a little program that says observed times expected. I'm sorry, observed, no, that wouldn't be right. Oh yeah. You could times your sample size by each of these for your L3. I think that should work. Yep, and then you can get these in your L3. Anyway, so make sure you tell this chi-square goodness of fit test, tell this the right L's then to be using for observed and expected. Okay, so where were we here? So we rejected. Okay, great. Now, we did find convincing evidence that the distribution of people with landlines is not equal to the true distribution of people that are in these different age categories. But what does that truly mean? Which areas were really the ones that were surprising then? Okay, so surprising to us is 141 compared to 200, or is 186 compared to 225, or is 224 compared to 221? No. Is 211 compared to 162, or is 286 compared to 238 more surprising? So what we have to consider is what value these are exactly and how far away they are from each other. So these two are about 60 away from each other. These two are about 40 away from each other. These two are very negligible. These two are about 50 away from each other, and these two are about 50 away from each other. So which one is more important though in the chi-square components? Well, what you can do is when you put all these values into your L1 and L2, and then you find your chi-square value, you can and should scroll to the right to see every component of the chi-square, just to see which component is largest, because remember that you're only summing up the different components, okay? And the largest components will result in the large value here, and those components just indicate that there's a large difference between these values. Realize that when you square, the difference becomes magnified, but becomes positive. So it doesn't always mean that the observed value or the expected value is inherently larger than the other. You actually have to look and see what actually happened, and was your observed value higher than it should have been, or was it lower than it should have been? Be sure that you can identify the difference. Okay, how do you do a follow-up analysis? Look for the category that resulted in the largest chi-square component. Look at whether you observed more or fewer than expected. A common mistake, large chi-square does not imply that you observed more than you expected to observe. Perform a follow-up analysis to the question above. So here's my chi-square components to the question above. The first difference squared divided by expected resulted in 17.49, then 6, then 0, then 14, 9. Okay, so which component was the biggest? I would say my 17 and my 14. Why was that? That was because 141 was so far from 200, but also, where was that 14? 1, 2, 3, my fourth category over. So the 211 was so different from 162. So we have observed too few people in the age group 20 to 29 having a landline, and way more people in the 50 to 59 age group having a landline. Would that make sense? Yeah, I think so. I think that cell phones were just coming out. 20 to 29-year-olds might not be interested in having a landline. They might not be really interested in being reached. Maybe they're still just renting, and they have cell phones instead. So they're not really interested in hearing anything from anybody. Okay, they don't pay taxes on the property. They're not really in charge of things. But 50 to 59-year-olds are like keeping up with all their cousins and their relatives, and they're still very much landline user, kind of landline friendly people. Okay, so I would write this. With respect to the various proportions of U.S. residents in the age groups, that just means keeping this accounted for, okay, that they're not equally distributed. The 20 to 29 group is responsible for the largest chi-square component, 17.49, due to much fewer than expected, 141 people versus 200 people answering a landline survey.